Welcome to this explainer. Today we're diving into a completely fascinating and honestly, kind of terrifying shift in modern history. We're going to explore how off-the-shelf commercial technology, combined with just pure, sheer battlefield desperation, has radically transformed modern warfare. We are effectively entering a brand new era of autonomous combat, and the speed at which this is all happening, it's staggering. So let's dive right into how the rules of war are being rewritten right before our eyes. Let's kick things off with Section 1, Desperation Breeds Battlefield Innovation.
Think about this reality for a second. Grassroots resistance forces are currently acting as dedicated manufacturing units. They're out there building, repairing, and even 3D printing customized drones for payloads. And where exactly are they getting the blueprints? YouTube tutorials. Literally. They've essentially managed to spin up an entirely homemade air force, giving them aerial capabilities that used to be strictly reserved for massive nation-states. It's a real game changer.
Now, the why behind all this DIY innovation becomes super obvious when you look at the sheer David versus Goliath military imbalance out there. We're talking about one side having 850,000 active personnel and over 12,000 tanks going up against 200,000 personnel and just about 2,500 tanks on the other. When you are outgunned and outnumbered to that massive of a degree, traditional tactics just don't cut it anymore. Outmanned forces desperately had to innovate with cheap, accessible tech just to survive. And this matters immensely because it proves that small, under-resourced groups anywhere in the world can now fundamentally challenge a traditional military superpower.
Moving right along to Section 2, a brief history of drones, because to really fully grasp how we got to the point of 3D printed bombers, we need to take a quick step back. The evolutionary arc of the unmanned aerial vehicle, or UAV, actually goes way back. We're talking mid-19th century, early experiments with gliders and balloons. Fast forward to the 1930s, and militaries were using radio-controlled aircraft, mostly just for target practice and reconnaissance. And then, of course, jumping to 1994, we saw the deployment of the iconic MQ-1B Predator drone, which completely flipped the script on targeted military strikes. Fun fact, the actual word drone has a surprisingly rich history. It originates from those early target practice aircraft I just mentioned, like the British Royal Navy's Queen Bee from the 1930s. It was a radio-controlled aircraft and is basically the great-grandfather of the tech dominating the skies today. Which brings us to Section 3, the DIY drone revolution. The contrast between civilian and military tech right now is absolutely mind-blowing. You've got your standard consumer drone, the exact kind of generic toy you might use for real estate photography or just buzzing around a park on the weekend. But then you compare it to that exact same technology, radically modified to drop live ordnance. It is literally an ordinary consumer product completely transformed into an instrument of war.
So why is this specific tech so incredibly popular? Well, it all comes down to the crazy specs and extreme cost-effectiveness. For roughly $2,000, about the price of a decent laptop, you can buy a drone that carries a 1-kilogram payload. It stays in the air for 40 minutes, flies at 47 miles per hour, and beams back high-def video from over 9 miles away. This technology has completely democratized air power. Anybody with a credit card and an internet connection suddenly has a highly capable aerial platform.
And to see the scrappy, resourceful ingenuity currently at play on the ground, just look at the RKG 1600. These started out as clunky, old Soviet anti-armor hand grenades, but forces have adapted them by adding delayed arming mechanisms and slapping on 3D printed tail fins. By doing this, they turn an outdated hand grenade into a stabilized, precision-guided bomblet designed specifically to be dropped from those cheap commercial UAVs we were just talking about.
Now let's look at Section 4, heavy hitters and motherships.
As this conflict has progressed, the tech hasn't just gotten more lethal, it's totally evolved in scale. We're moving way beyond small, modified quadcopters and stepping into the territory of heavy-hitting custom UAVs and tactical motherships. Take the Dovbush T-10. This is absolutely not a consumer toy. It's a custom-built, fixed-wing aircraft with a massive 4.5-meter wingspan powered by a low-noise electric motor. It costs between $12,000 and $15,000 to produce, boasts a 15-kilogram payload capacity, and serves a very specific, terrifying purpose on the battlefield.
Let's break down how they actually deploy this thing, because this is where modern tactics get incredibly sophisticated. Step 1. The human pilot stays safely out of range, miles away from the actual danger zone. Step 2. The DOBOSUH T-10 acts as a mothership, flying deep into enemy territory. Step 3. Once it's over the target area, This airborne aircraft carrier releases a swarm of up to 6 smaller first-person view, or FPV drones. These smaller drones then swoop in to strike enemy targets like tanks, while the pilot sits completely untouched.
To really put the economics of all this into perspective, just compare the custom Vampire drone, also known as the Baba Yaga, to a traditional military-grade drone. The Vampire costs just $10,000 and can carry 4 heavy anti-tank bombs. On the flip side, you have the traditional Bayraktar TB2, which carries a much larger payload, but costs anywhere from $2 to $5 million. This comparison hits the nail on the head. Cheap, heavy-lift drones are actively replacing traditional, wildly expensive military hardware. The return on investment is just undeniable.
That brings us to Section 5, Countermeasures and Russian UAVs. Of course, war is a constant game of cat and mouse. For every single offensive innovation we've looked at, there's a frantic, desperate scramble to develop countermeasures. Militaries are throwing literally everything they have at the sky right now to stop these incoming swarms. The methods currently in use run the entire technological spectrum. At the high end, you've got sophisticated electromagnetic pulses, signal jamming, high-powered lasers, and surface-to-air missiles. But at the low end, you have soldiers standing in trenches, desperately firing shotguns into the air, just hoping to hit a fast-moving piece of plastic before it drops a grenade on them.
This arms race has even kicked off an era of dedicated drone-on-drone warfare. Take the Skyfall P1SUN. This is a 3D printed interceptor drone designed purely to hunt down other drones. It cruises at a blistering 280 miles per hour. We are quite literally watching robotic dogfights happen in the skies right now, powered by 3D printed parts that cost only a few $1,000s to make.
But while grassroots forces are 3D printing interceptors, state-backed manufacturing is scaling up to an astonishing degree. 26,000. Let that number sink in. That is the number of Iranian-designed Shahed 136 kamikaze drones that Russia has reportedly produced to date. It just goes to show how major military powers are fully leaning into this cheap, unmanned strategy, pumping out these weapons at a scale that is incredibly difficult to defend against.
And they're using a starkly varied fleet to achieve different strategic goals. On one hand, they rely heavily on that Shahed 136, a relatively cheap, $20,000 explosive kamikaze drone designed to just overwhelm air defenses through sheer volume. But alongside it, they operate drones like the Orlan 10. This one costs around $100,000 and is built for prolonged, 16-hour endurance missions focused on mapping and electronic warfare. It is a very calculated, dual-pronged approach to unmanned combat.
Finally, let's look at Section 6, the future of unmanned warfare.
The crucial takeaway from all this is the pure velocity of change. If we've gone from modifying consumer cameras to 3D printed bomber swarms and drone-on-drone dogfights in just a handful of years, where on earth does this technology go next? As we look at the R&D currently underway, the evolution of drone warfare is moving rapidly away from remote-controlled gadgets and directly into the realm of science fiction.
The immediate future involves some major leaps forward. We're talking about enhanced stealth materials, making drones virtually undetectable. We'll see advanced swarming capabilities, where massive groups of drones communicate and work together to maximize destruction. Plus, militaries are heavily investing in collaborative combat aircraft, or CCAs. Think advanced unmanned jets designed to fly right alongside human fighter pilots. It completely changes the dynamic of aerial combat. But perhaps the most transformative, and let's be honest, concerning shift is the push for true autonomy. Artificial intelligence is rapidly enabling drones to operate with significantly reduced human intervention. They're gaining the ability to navigate autonomously, avoid obstacles, and, most importantly, make real-time strategic combat decisions entirely on their own.
Which leaves us with one final, profound thought to consider before we wrap up today's explainer. What happens to global security, to the ethics of conflict, and to the very rules of war, when the decision to pull the trigger is no longer made by a human being looking at a screen, but is outsourced entirely to an algorithm? It's a massive, undeniable shift in human history, and one we are all going to have to navigate very, very soon. Thanks so much for joining me for this explainer. I hope it gave you a clearer picture of the rapidly changing realities of modern warfare.